What if the most ambitious construction project in human history had no construction workers? No hard hats, no cranes operated by human hands, no astronauts laying foundations, just machines building other machines on the surface of the moon. Right now, as you watch this video, a plan is quietly being executed that most people don't know exists. Not a Mars plan, not a distant dream for the 20-teens, a moon plan. And it could begin within this decade. SpaceX and Elon Musk have pivoted, and the reason why tells us everything about where humanity is actually headed. For years, Elon Musk told us Mars was the goal, the backup drive for human civilization, a second planet, an insurance policy against extinction. And the vision was intoxicating. But here's the brutal truth that scientists, engineers, and even SpaceX's own mission planners kept running into: Mars wants to kill you, and it doesn't apologize. A one-way trip to Mars takes between 6 and 9 months, depending on where the two planets align in their orbits. And those alignment windows, they only open once every 26 months. That means if something goes wrong, a medical emergency, a structural failure, a life support malfunction, you don't get a rescue mission. You don't get a second chance. You get a eulogy. The radiation exposure alone during a Mars transit is equivalent to receiving thousands of chest X-rays. And once you land, you're bathed in solar and cosmic radiation because Mars has no protective magnetic field. The psychological toll of being 140 million miles from Earth, with a 24-minute communications delay with no chance of return, that's not an engineering problem. That's a human problem, and humans are notoriously bad at being stranded. So quietly, methodically, the calculus changed. The moon is 238,000 miles away. That sounds far. But at the speed of a Starship rocket, you can get there in roughly 3 days. 3 days. If something catastrophic happens on a lunar base, a pressure leak, a power failure, a medical crisis, you can be back on Earth before your situation becomes fatal. That single fact rewrites the entire risk equation. But the moon isn't just a safer Mars. It's something far more strategically interesting. The moon has water ice confirmed, locked in permanently shadowed craters near the poles. Water means drinking. Water means oxygen when split by electrolysis. And hydrogen from that same water? That's rocket fuel. The moon has silicon, aluminum, iron, and titanium, all the raw materials of industry sitting in the regolith, the loose surface soil just waiting to be processed. And the moon has something Mars could never offer: proximity to Earth's economy. Every satellite launched from the moon costs a fraction of what it costs from Earth's deep gravity well. Every product manufactured in space and dropped toward Earth arrives faster and cheaper if it starts from the moon. The moon isn't a stepping stone to Mars. The moon is the destination, at least for now. Here's where the plan gets genuinely strange and genuinely brilliant. SpaceX isn't planning to send thousands of humans to the moon to build a city. They're planning to send robots and let the robots build the city for humans. Think about what that means for a moment. The traditional model of space colonization imagines waves of astronauts, each one carrying expensive equipment, each one consuming oxygen and food and water, each one vulnerable to radiation and pressure loss and the 1,000 ways space tries to end you. The new model sends robots first. Robots that can work 24 hours a day. Robots that don't need air. Robots that don't get homesick. Robots that, here's the key part, can build more robots. This is the concept of a self-growing city, and the technology to do it is remarkably already being developed right here on Earth. Tesla's Optimus robot, originally designed for factory floors, is being re-engineered for lunar operations. These humanoid machines can manipulate tools, carry materials, operate in hazardous environments, and crucially, you operate under AI instruction without constant human supervision. The plan works in stages. Stage 1. Starship rockets, the largest and most powerful rockets ever built, begin delivering equipment to the lunar surface: mining drones, processing units, power systems, seed factories. Stage 2, the seed factories begin. They mine lunar regolith, extract raw materials, process them into usable components, and begin constructing more equipment, more robots, more factories. Stage 3, the factories start producing things the Earth actually wants. And that's where this stops being a science project and starts being a business. Here on Earth, we are in the middle of an AI explosion that most people are still struggling to comprehend. The demand for computing power is growing faster than our ability to build data centers. We're running out of land. We're running out of cheap power. We're running out of the ability to cool the machines that run the models that power everything from your phone to your bank to your hospital. What if you move the data centers off the planet? SpaceX's lunar plan includes the construction of orbital data center satellites, server clusters launched into orbit that can beam processing power and data storage down to Earth without consuming a single acre of land, without requiring cooling water, and powered entirely by the sun. And the moon is the perfect place to build them. The raw materials are there, the robots are there, and most importantly, the launch costs from the moon are a fraction of what they are from Earth. Here's why. To launch something from Earth, you have to fight our planet's powerful gravity. Earth's surface gravity is 9.8 meters per second squared. The moon's gravity, just 1.6. You need 6 times less energy to escape the moon than to escape Earth. That difference is worth billions of dollars per launch, possibly trillions over a generation. If robot-built satellite factories on the moon sound ambitious, this next part sounds like science fiction. It is not. SpaceX's plan includes building what engineers call a mass driver, a railgun launcher that uses electromagnetic force to accelerate payloads to lunar escape velocity and fling them directly into orbit. No rocket, no fuel, no explosion, just electricity, magnets, and physics. On Earth, this is almost impossible. Our atmosphere creates so much drag that any object accelerated to orbital velocity at the surface would burn up before it reached space. Our gravity demands enormous energy. On the moon, no atmosphere, low gravity. The equations flip entirely. A lunar mass driver could be several kilometers long, built by robots, of course, and powered by solar energy. It could launch satellites, raw materials, and cargo into orbit continuously at a cost per kilogram that makes conventional rocketry look medieval. The energy comes from the sun. The materials come from the moon. The machines that build it were sent by Starship and then replicated on site. The whole system is almost poetically self-sufficient. But what about the humans? Eventually, people will need to live on the moon. Engineers, scientists, mission controllers, and housing them safely is one of the hardest problems in space architecture. The solution SpaceX is exploring is both elegant and slightly mind-bending. When a Starship delivers its cargo to the moon, it leaves behind an empty shell, a hull of ultra-high-grade steel designed to survive re-entry heat and the vacuum of space. Rather than returning that shell to Earth or letting it sit unused, the plan involves burying these Starship bodies under several meters of lunar regolith. That soil becomes the radiation shield. Space radiation is relentless. Without Earth's magnetic field and atmosphere, the lunar surface is constantly bombarded by solar flares and galactic cosmic rays. But a few meters of compacted lunar soil reduces that radiation to manageable levels. The buried Starship becomes a pressurized habitat. Add life support, power, communications, and interior fittings, and you have a home. One that cost almost nothing extra to build because the structure was already going to be there anyway. This is SpaceX thinking like engineers, not architects. Every component does double duty. On the lunar surface, you need to move things. Robots, materials, equipment across a terrain that is equal parts beautiful and treacherous. The moon's surface is covered in fine, abrasive dust that clogs mechanical joints and degrades solar panels. The terrain is pockmarked by craters ranging from basketball-sized to city block-wide. Temperatures swing from 127 degrees Celsius in sunlight to minus 173 in shadow. You need a vehicle that is simple, electric, pressurized if necessary, and almost impossible to break. Tesla's Cybertruck platform, stainless steel body, electric drivetrain, flat angular design, is being studied as the design ancestor of next-generation lunar rovers. Adapted for the moon, These vehicles would be fully electric. The moon has no refueling stations, but it has sunlight for solar charging. They'd be remotely piloted or fully autonomous, driven by the same AI systems that power Tesla's full self-driving technology. They'd carry robots to work sites, they'd haul mined materials to processing plants, and they'd move fast across the lunar plain, connecting the growing city like a circulatory system. Every city needs power. A lunar city needs power more than most. Mining operations are power-hungry. Factories consume electricity continuously. Life support systems must never fail. The mass driver that launches satellites requires enormous bursts of electromagnetic energy. The plan, solar at scale, manufactured on the moon. Tesla is already one of the largest solar panel manufacturers on Earth. The same factories producing panels for suburban rooftops are refining processes that could, in theory, be replicated using lunar silicon. In the short term, Starship deliveries will bring high-efficiency solar arrays to the moon's surface. But the long-term vision is to use the moon's own silicon, one of the most abundant elements in lunar regolith, to manufacture solar panels directly on the moon. Some of those panels would power the surface city. Others would be launched into orbit, attached to satellites and space-based power stations that beam energy back to Earth, or power the orbital factories themselves. The entire system, city, factories, mass driver, satellites, runs on sunlight. No fuel supply chain from Earth, no dependence on resources that run out. The moon becomes energetically sovereign. Step back and look at what's being described here. A city that builds itself. Robots that make robots. Factories that make factories. A launch system that requires no rocket fuel. Habitats assembled from leftover spacecraft. Vehicles descended from electric trucks, power generated by the closest star. This is not a colony in the traditional sense. Humans arriving to struggle against an alien environment. This is something closer to a civilization seeding itself into space using the tools of automation, artificial intelligence, and radical engineering. And here's the part that rarely gets discussed. If this works on the moon, 3 days from Earth, with rescue possible, with constant communication in a relatively understood environment, then we will have built the playbook for Mars. When every robot design tested on the moon goes to Mars better, every habitat solution proven in lunar conditions becomes a Mars blueprint. Every mass driver technique, every regolith processing method, every solar manufacturing process, it all transfers. The moon isn't the destination instead of Mars. The moon is how we earn Mars. What Elon Musk and SpaceX are attempting with this lunar city plan is, regardless of what you think of the people behind it, one of the most technically ambitious projects in the history of our species. It could fail. Many of the hardest parts haven't been solved yet. Robotic autonomy on the lunar surface is still in early stages. Mass drivers exist only in theory and small prototypes. Mining lunar regolith at industrial scale has never been done. But the roadmap exists. The funding exists. The technology is closer than it's ever been. And if it works, the moon will stop being a thing we look at from the ground. It will become a place we live. If you made it this far, you're exactly the kind of person this channel exists for. Hit that subscribe button, because we cover the plans, technologies, and ideas that are quietly reshaping civilizations. You know, so most people won't hear about this for years. You just heard it now. Drop a comment below. Do you think this lunar city will actually be built by 2035? Or is this another bold vision that runs into the wall of reality? See you in the next one.